Alright, so today we're going to be learning about the ideal gas law, and that is a gas law that helps us determine information about a gas at one set of conditions. So what's the pressure of the gas, the volume, the temperature, how many moles of the gas are there. So that's what the ideal gas law does. So we have to use specific units when we're talking about the ideal gas law. For pressure, you have to use ATM. Volume, we're going to use liters. We're going to use N is going to stand for moles, so moles. Temperature, we're going to use Kelvin. And R, that R value that's in there is a constant, so it'll be the same number every time. It'll be 0.0821 liter atmospheres per mole Kelvin, and you will be responsible for memorizing this number. So you have to memorize this, okay? And then our ideal gas law actually is PV equals nRT. So the pressure times the volume equals the moles times the constant of R times the temperature in Kelvin. So let's give two examples a try. Alright, so our first example, how many moles of a gas at 100 degrees Celsius does it take to fill a 1 liter flask to a pressure of 1.5 atmospheres? So you'll notice I've lined up my variables along the side. I can fill in R, because I know that it's always the same, 0.0821 liters times atmospheres all over moles times Kelvin, okay? Times Kelvin. All right, now I can go through. I've got 100 degrees C, but I have to convert that to Kelvin. So I do that by adding 273, so that'll be 100 plus 273 equals 373 Kelvin. All right, and then I've got a 1 liter flask, so that's my volume, 1.0 liters. And then I've got a pressure of 1.5 ATMs. And you can see N is what I'm looking for. I'm looking for my moles. So now what I'm going to do is I'm going to set up my PV equals lowercase n, capital R, capital T. All right. Now I can fill in the information that I have. So I have 1.5 ATMs times 1 liter equals my moles, which is what I'm looking for, so my variable N will stay, times 0.028 liter atmospheres per mole Kelvin, right, times temperature Kelvin. And the reason that our value of R is as it is, you can see my units are going to cancel out, okay? So in the denominator, I've got moles and I've got Kelvin, because those will cancel out. On this side, on the numerator, I've got liters and atmospheres, which are liters and atmospheres on the other side. So your value of R is a constant, and it has that mixed unit to help balance out those units, okay? So what I'm going to do is I'm going to take my 1.5 and my 1, I'm going to multiply them together. And then I'm going to divide by 0.0821 and by 373. I should get a value of N being equal to 0.049 moles. Sorry, my pen is not working properly today. Okay, 0.049 moles. And that's a very straightforward problem. You'll have 4 of the 5 variables. Solve for the 5th variable. Okay? Remember, you'll never be asked to find R. You will always have R. That's a given. Okay? Example number 2. Okay? On a warm day, a balloon is filled with 47.8 grams of helium. The temperature is 33 degrees C, and the pressure is 2.25 atms. What is the volume of the balloon? Well, I know I'm looking for volume, so I can put a question mark there. All right, I've got a pressure right here. All right, moles. I've got no moles. But what I do have right here is I've got grams of helium. So what I can do is up at the top here, I'm going to convert to moles. So I'm going to do 47.8 grams of helium over 1. And then I'm going to use my molar mass to convert to moles. So I know that's 4.0 grams of helium. This comes straight from the periodic table, is 1 mole. Okay, So I should be getting that my moles here is actually 11.95 moles. So sometimes you have to do a little bit of extra math before you can figure out what your responses are. So if you're given grams, use your molar mass to go to moles. So I've got 11.95 moles in there. And then, all right, I've got temperature. I've got 33 degrees Celsius, so 33 plus 273 is going to be 308 Kelvin. And then I've got my standard R value. R is always 0.0821 liter atmospheres per mole Kelvin. All right, so now I'm going to start with my ideal gas law. P, V equals N, R, T. All right, so let's do my pressure. I've got 2.25 ATMs times my volume V, that's what I'm looking for, equals my number of moles, which is 11.95 moles, times my R value, which is 0.0821. Remember, that's liter atmospheres per mole Kelvin. And then I'm going to also multiply that by my temperature in Kelvin, which is going to be 308 Kelvin. All right, now the same thing, I'm going to multiply one side of my equation to get a simplified answer. So I have 11.95 times 0.0821 times 308. And then I'm going to divide by 2.25 to get my volume. So my volume should be equal to 133.43. And what's my unit? Well, it's volume, so it's got to be liters. Okay, these are threes. Sorry about that. All right, and that is our ideal gas law. Nice work.